Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the deflating process. In addition to a large number of stable fluids in engineering, there are also some unsteady fluids. The deflating process is a typical unstable flow. When deflating, in addition to the flow rate changes with time, the state of the gas in the container also changes with time. Generally, it can be considered that at any instant, the state of the gas in the entire container is approximately uniform. Pressure and temperature is consistent. The deflating process means that the higher pressure gas in the container is discharged to the surroundings. Now, let's take the gas in the container as the thermodynamic system, and its volume V is unchanged. The temperature of the gas in the container before deflating is T1. The pressure is P1 and the mass is M1. After deflating, the pressure drops to P2. The temperature becomes T2 and the mass decreases to M2. Similar to the inflating process, the deflating process also can be classified into two processes, that is, adiabatic and isothermal process. According to the basic expression of the first law, that is, equation 2,4, we have the following expressions for the deflating process. Then we have the general energy equation of the deflating process. This is equation 8,106. Let's firstly talk about the fast or adiabatic deflating process. For the adiabatic deflating, the general energy equation, equation 8,106, is simplified as: if the gas in the container is an ideal gas with a specific heat, we then have, where T is the temperature of the gas in the container, and it keeps decreasing during the adiabatic deflating process. The deflating process under adiabatic conditions can usually be regarded as a constant entropy expansion process. So the relationship between the temperature and the pressure of the gas in the container is: when the pressure drops to P2, the temperature in the container then is. At this time, the mass of gas remained in the container then is. The gas mass released then is. Now, let's talk about the slow or isothermal deflating process. For the isothermal deflating, if the gas is treated as an ideal gas with a constant specific heat, then the general energy equation for deflating process, equation 106, is simplified as: it indicates that the heat absorbed by the ideal gas with constant specific heat during the isothermal deflating process has nothing to do with the gas temperature, nor with the specific heat and gas constant, but only depends on the volume and pressure drop of the container. Okay, that's all for this task. Thank you very much and see you next time.